I think audio is right. I am audible. Okay. Hello everyone, welcome to another live session. Today we are going to discuss about number system, and we have already discussed about rational numbers and small intro about irrational numbers. But don't worry, we shall again discuss about irrational numbers and the real line representation of irrational number also today. We are going to discuss a brief description such that we can move forward fastly. Okay, let's start. At first, I shall introduce the irrational number, the definition again. Okay, here I am writing. Okay. Those numbers which has decimal expression as non-terminating and also non-repeating is irrational number. That means a number which can neither be expressed as a terminating decimal or a repeating decimal. If it is non-terminating, then it must not be repeating. Okay, I am writing this here. Repeating decimal is called irrational number. Okay, so let me take some example. As here it is 0.1, 001, 0001, 00001 and so on. So here you can see a pattern is not following. The pattern are different here. Okay, so it is non-repeating. So definitely it is irrational. Like this. Again, if A is, we have discussed it before. If you have not watched the previous video, then go please, there is a playlist in my channel named the number system. Go and check it out. Okay. If A is not a perfect square, then definitely root over A is irrational. And if A is not a perfect cube, then definitely 3 root of A or cube root of A, whatever you say, is definitely an irrational number. Okay, as example, root over 2, root over 3, root over 5, root over 10, root over 6, etc. and many more. And again, cube root of 2, cube root of 4, because 4 is not a perfect cube. Okay, cube root of 7 also true, cube root of 10, cube root of 20, cube root of 16, because 16 is not a perfect square, perfect cube. It is a perfect square maybe, but it is not a perfect cube. Okay. Another topic we have discussed is earlier, that pi is irrational number, but 22/7 is a rational number. We have discussed it again, because for to make the calculation easier, we always assume that pi is 22/7, but it's not the actual value. It is approximate value up to 22/7. Yeah. Again, we have discussed about the properties of irrational numbers. Properties about irrational numbers means like this. This one is another property, that a rational plus minus irrational, always irrational. Okay, and irrational plus minus irrational, may be rational or it may be irrational. And irrational if I am taking the multiplication with an irrational, then it may be rational or may be irrational. Okay. Another is, if a rational multiplication with irrational, definitely irrational. Positive. Okay, and again, irrational division irrational, it may be rational or may be irrational. Yeah. And a rational division irrational, obviously it will be a irrational number, or maybe a rational number also true, I think. No, it may be always irrational. Okay, it will always be irrational, I hope. Okay, let me take some example as it, like, right, yeah, like 2 plus minus root 3 always be irrational. Okay, now 2 plus root 3 plus 2 minus root 3, both are irrational numbers and their sum is 4, so it is a rational number. But this one is irrational, this one is also irrational. Okay, again, maybe root over 7 and root over 2, if we multiply them, then it will be root over 14, that is irrational. But if we multiply 2 root 3 into root 3, then that will be 18, is rational. That will be 6, sorry. Rational. And then we have excess before us. Next. Okay. Finding irrational numbers between two irrational. We have discussed that A and B are two distinct positive rational numbers. two distinct positive rational numbers, then definitely root over a into b is not is lying between a and b also, and it is a irrational number. Now, okay, is this true that square root of all positive integers are irrational? Is it true? Is square root of all positive integers are irrational? Is it always true? It is not true, because 4 and 9 both are positive integers. Okay. Then root over 4 is 2, root over 9 is 3, and both are rationals, not irrational. So this statement is not true. Have you got it? Yeah, they are. Which one is not perfect square? Like 7 is positive integer but not perfect square. So definitely root over 7 is irrational. Yeah, this is also true, we have discussed before. But this one and this one, both are perfect squares. So it totally depends on the manner of the number. Okay. This is to question you. Then find rational number, rational and irrational number also. Between 3 and 4. This is my first question. This is another second question is find two rational and irrational between root over 2 and root over 3. So I am giving you some time. You take some time and please do this sum yourself, and I will be right back after some time and discuss it again. Okay. do it. First, question number 1. The two numbers are 3 and 4. Both are rational numbers, and to find rational number lying between them, we just have to create the mean of them. So 3 plus 4 whole by 2, that is 7 by 2. Okay. Here it is rational number. On another process is if I have to create more rational numbers lying between them. So just make them form in fractional and multiplying in both sides with n plus 1. If I have to create 3 rational numbers, so n is 3, so n plus 1 will be 4. Just create 12 by 4 and multiplying in numerator and denominator also with 4, so 16 by 4. So 3 means 12 by 4 and 4 means 16 by 4. And just here you can see that the denominator are same. Just compare the denominators also. That will be 13 by 4, 14 by 4 and 15 by 4. So this is how you crack this sum. Now you have to find the irrational numbers lying between 3 and 4. So that is, here it is 4, here it is 3, and root over 3 into 4. We have discussed it before that if a and b two rational numbers, then lying between them the irrational number is root over ab. So that will be root over 12. Okay. Next, number 2 is root over 2 and root over 3. Root over 2 and here root over 3. This is question number 2. So we all know that root over 3 is greater than 2, as 3 is greater than 2, so root over 3 is greater than root over 2. Okay. But I have to know that the decimal expression of these two rational numbers, that is root over 2 means 1.4142135 and so on. It is non-repeating, non-terminating decimal expression. It is also non-repeating and non-terminating decimal expression, that is 1.7320500807. So I have to create two rational numbers lying between them. Here I am writing that it is 1.4142135 and here it is 1.7320500807. Okay, and so on. Also, this is non-repeating decimal expression, definitely. Yeah. At first, I am inserting some rational numbers. The rational number is terminating decimal expression. So if I take a decimal expression lying between them which terminates after some finite steps, that is, if 1.41 and here 1.73, so in the second digit after the decimal it is 1 and in the second digit after the decimal it is 3, and in the first digit after the decimal is 7, here the first digit after the decimal is 4. So if I take 1.5, yes, 1.5 is absolutely greater than 1.41421, definitely, because the first term is greater than this, the first term, decimal first term, okay, of the decimal first term. And here the first term of this decimal expression is greater than this one, so this is definitely lying between them. And if I terminate 6 here, so it is basically a rational number, okay. Next, another one is if I take 1.6, yes, 1.6, because the first digit after the decimal expression is 6, and here first digit after the decimal is 4, and here first digit after the decimal is 7. So 6 is lying between 7 and 4, so definitely 1.6 also lying between these two numbers, these rational numbers. And if I create more digit after this steps, a finite number of steps, so this will also happen if I take 5, 7 and 4, 3, pass, nothing else, yes, all that. So this is definitely a rational number because it terminates. This also rational number because it terminates. And these two numbers are lying between these two, okay. Next is the similar kind process. We just reminded that to create a irrational number we cannot terminate the decimal expression and we cannot repeat the decimal expression, just remember it. So one number is 1.41421356 and so on, and second number is 1.7320508007 and so on. So if I take two rational numbers like this one is 1, this 1 point, okay, I am taking 4 as well because here it is 4 and here it is 7, okay, I can write. Next is here it is 1. If I take a single digit greater than 1, then it's definitely lying between them, okay. Now my topic is that if I take a non-repeating decimal expression, so then definitely it lying between, it will be a irrational number lying between them. So next term is, okay, here the second term is 3, here it is second term is 1, so definitely this number is already lying between them. So we have to create a irrational number like this. I am taking 2 0 0 0 2 0 0 0 2 0 0 0 0 2. I can create as it, or I can take okay, also I can write like this 1.4212111211122. Yes, also I can write like this. Another one I have taken that. Or I can write like this. If I take here it is 5, yes, definitely 5 lying between 4 and 7 also. So if I take like 3, yeah, then 5 3 3 5 3 3 3 and so on, so that will be an irrational number. So we can make various kind of irrational number lying between them. Okay, next time this is some to you. Find irrational numbers as your choice. Between like 2.1 3 1 3 3 1 3 3 3 1 3 3 3 3 and so on, and another is 2 point, here it is 4 5 0 5 5 0 5 5 5 0 5 5 5 5 0 and so on. This is your task. I am giving you some time according as the similar process. Okay, I am making it smaller so that you can see the whole page. Yeah, take some time and do this. Okay, next, here I am doing this sum 2.13133131333 and so on. Another number is 2.50555055505550 and so on. Okay, here it is the first digit. Okay, I am making it highlight. This one is first term, this one is first term. So if I take a term which is lying between them, then 1 and 5, that will be also 2 is true, yes, that will be also 3 is true, that will be also 2.4, and then I am creating an irrational number myself as it is 1 2 2 1 2 2 2 1 2 2 2 2 1 and so on. And next is 5 0 4 5 0 4 0 4 5 0 4 0 4 0 4 5 and so on. And next, okay, making it as 3 9 3 9 9 9 3 9 9 9 9 3 9 9 9 9 9 3 and so on. So these all are irrational numbers lying between them. So you can make also various kind of irrational numbers lying between numbers, any kind of numbers. It may be rational numbers, it may be irrational numbers. You can make various kind of irrational numbers, also rational numbers like this. Okay. Now I have to find two irrational numbers lying between them, like this. Okay, this is your task. Find two rational between this. One is 0.3, 6 3 6 6 3 6 6 6 3 and so on, and another is 0.34 344 3444 34444 3 and so on. So just write the number here 0.36366 36666 3 and so on, and another number is 0.34 344 3444 3 yeah. Now my task is to find rational numbers. So rational number is or terminating or recurring decimal expression. So if I take terminate here like 3.6 plus nothing else. Another is 0.36. Another topic, another thing. I can also take 3.5 as well, because 5, 4 and 6 lying between 5. Yes. Another is 0.35 bar. Yes. Another is 0.345. 4 5 is bar. Yes, because 4 and 5 here, 4 and 3, because it is the third digit after the second digit after the decimal and third digit after decimal. Here the second digit after decimal is 4, here the third digit after decimal is 3. So if I make it bigger, then that is easily lying between them. Okay, and if I take this bar, so it indicates that it is a recurring decimal expression, so it is a rational number as well. Yeah, and these two are terminating. These two are terminating, and these two are recurring. Here you can make various rational numbers. So now you have to just create them as P by Q, which you can do easily because we have discussed it earlier. Okay. Next is real numbers. Real numbers means this contains natural numbers, this contains whole number, this contains integers, this contains rational numbers also, and this contains irrational number. So all the numbers we have learned till today, all numbers making together real number. Real number is just like a space, real space. In higher mathematics, it is called as vector space as well. So the proper definition: a number whose square is non-negative is called real numbers. Yes, a number whose square is non-negative is real number. It is a standard definition. because whatever you number you take, the square of that number cannot be uh, non-negative if you take the number from this 6. Okay, like if you take root over minus root over 7, yes, its square will be 7. Yes, if you take 3 by 7, whose whole square will be 3 by 49, that will be non-negative. That will be non-negative. If you take 0 also, 0 square will be 0, is non-negative. That means the square of the negative cannot be, square of the number cannot be negative. If the number is positive, then definitely it means that its square will be non-negative, definitely. And it is trivially true. Okay, now some properties here, and these properties you already know. Closure property at first. Closure property means the sum or multiplication or division, also subtraction, are all between two real numbers, always be real numbers. So the closure property defines that binary operation between two real numbers, you can get back a real number also. Binary operation means plus, it may be minus, it may be multiplication, it may be division. Here next, associativity. Under addition, that is a plus b. We are mentioning it here under addition. Next, commutative property also it is under addition. Next, additive identity. That is 0, because if we sum 0 with a number like a, and we can get back a, where a is real number for any real number. Another is multiplicative identity. That will be 1, because if we multiply a number with 1, and you can get the number as well for any real number. Next one is additive inverse. If A is a real number, then definitely there is a number B such that A plus B will be 0. So B must be minus of A for any real number A. And next one is multiplicative identity. Multiplicative inverse. Because we have already have discussed before. So it will be inverse. That will be A. I am taking A, and if I multiply with B, and we can get the multiplicative identity, that is 1. So B must be 1 by A, and it is also a rational, a real number if it is a real number, and it is also a real number here. So now some exercise we have to do that is very trivial. It's my question. Some. But first, plus another one is yes. This is how happened. Here 3 root 2 plus 7 root over 3 plus root over 2 minus 5 root 7. And now here you can see that these two root over are same here. It is 2 and 2. So D2 will be, this will be, the binary operation happened. What is it, the binary operation? It is plus, and these two are different. So we are rearranging this like this. 3 root 2 plus root over 2 here plus 7 root 3 minus root over 7, and that will be, here it is 1. So definitely that will be 4 root 2 plus 7 root over 3 minus 5 root over 7. So we cannot go there it is. Next one is this one. Number 2 is just multiply between. So here it is except the root over, so I am multiplying this as well. And here root over 11 into root over 11. So that will be 15 into root over 11 into root over 11. Because you all know this, root over A into root over B, that will be root over AB. but this is not possible. Okay, here I am writing that is a root over a plus root over b is not equals to root over a plus b. It's not possible. Yeah. Okay, so that will be 15 into here between the root over is root over 11 square, that will be 11, that will be 5, 6, 65. Next, this one 15 of root over 15, 3 root over 55. Now there is cancellation in them, so 3 factors are cut out. That will be 5 root over 15 by 5. Okay, I am writing it here as multiplication. That will also happen, that root over a by b equals root over a by b. This happened. So here it is 5 3. Also you can track it another method, that is 15 root over 15 by 3 root over 5. So here you can write as well. 15 means 5 into 3 by 3 root over 5. So 5 into 3 in the root over means this one. That will be 15 into, we can make it separate as well, because here it is the multiplication. So root over 5 into root over 3 by 3 into root over 5. So here root over 5 root over 5 cancel out, and here the common factors are 3, so cancel out will be 5 root over 3 as well. Next is, this is to simplify that. Simplify it, that is root over a square minus b square by root over a square plus b square, and here it comes plus a plus b, division sign. Here it is root over a square plus b square. Here it is minus b, a by root over a square minus b square. So we have already know that a by b division c by d happens. Then to convert it to multiplication, we just make it the reciprocal like this. Okay, so here is the answer. The left part is as well, it is, I am writing, but here I am converting it to multiplication, so I am making it the reciprocal. So a minus root over a square minus b square, and then root over a square plus b square minus b. So this is plus, so we can make it commutative property by commutative property. So we can write like this. Here you can this go. Okay. You also know this. X minus y into x plus y, that will be x squared minus y squared. So here you can see a plus this one, and here it is a minus this one. Okay. So a plus root over a square minus b square into a minus root over a square minus b square by this happens. So a square plus b square plus b and root over a square plus b square minus b. Okay. So here is the a plus b into a minus b form. This is a, so x plus y into x minus y, and this is my y one. I am making it so clear. And in this the denominator section, this is my x, and this is my y as well. So we can write like this: x plus y, x minus y. So x square minus y square, that will be a square minus this one square. Here x plus y, x minus 1, that will be a square plus b square whole square minus b square. Yeah. And next thing is that root over a upon whole square will be a as well. So here it comes a square minus, so the root over will be cancelled out as well, that will be a square minus b square. Here it is also root over cancel out, a square plus b square. Okay, that will be a square. I am taking out the bracket, so a square minus a square plus b square, because there is a minus symbol outside the bracket. So if I take out the bracket, the symbol will be opposite simultaneously as well here. Okay, so here is the cancellation like this, because a square minus a square cancel out, b square minus b square cancel out. So b square by a square is my answer. Or you can write like this, b by a whole square. So we will come to it later when we discuss about exponents. Look at this sum very closely. Here it is. And making it clear, crystal clear. Next is very important thing, that is representing irrational number in real line. How you can represent a irrational number in on the real line. Okay, at first we should represent root over 2. So I all know that root over 2 means root over 1 plus 1. Okay, now I am taking a line as real line and name it, that is x and x dash. Here I am taking the 0 element. Okay, here I am taking 1, and this the difference is 1 unit. Another I am taking 2 as well, another I am taking 3 as well, 4 as well, and all the difference are 1 unit. So I am naming it as O and it is my A. Okay, so this one is 1 unit. Now I am taking a perpendicular line above A here of length 1 unit. So this is also 1 unit. This is also 1 unit. Yeah. Now I am naming it as B. Okay. I am removing A here and I am writing A here. Now I am joining that O and B as well. So you can see it is a right angle triangle. Okay, right now. So if the length is here is 1 unit, it is 1 unit, then this one is by Pythagoras formula, it will be root over 1 square plus 1 square, that will be root over 2. So this is the length of 2. Here it is length of 2 as well. This one. Okay, now I am taking the length OB and make a arc on the real line by a compass, and that will cut it at this point. I am naming it as E. So E is the position of rubber 2. Here you can get the position. Okay. Next is root over 3. Root over 3 means 2 plus 1. That means 2 means root over 2 whole square, and another is 1 square. So this is the length of root over 2. So here I am creating a perpendicular line of length 1 as well. Okay, this is 1 unit as well, and I am mentioning it as C, and now I am joining this O and C. Okay, so this OC will be OE square plus EC square and root over of them. So that will be OE means root over 2 length. So this is root over 2 whole square plus EC means 1 length 1 square, and that will be root over 2 plus 1, that is root over 3. So OC length is root over 3 here. So just take the OC and make a arc on it. So that will be, I am naming it F, so that is root over 3. So here you can create root over 5 as well, because root over 5 means 2 square plus 1. Okay, that is 4 plus 1. Okay, I am mentioning it before again. 5 means 4 plus 1. So you can take a, here, I am writing. You just take a length of 2. Here it is O, here it is A, here it is B. So this is my length of 2 here. This is length of 2. Here I am taking a 1 length. And here I am getting a perpendicular, this right triangle, and that will be what? This is 2, this is 1. So that will be root over 2 square plus 1 square, that will be 5 root over 5, and make it R. Okay. So this is how you can represent root over 2, 3, 5, root over 7 as well on the real line. Okay. Now, generalized version, that is existence of root over x for a given real number x. So this is the technique, that is at first I am taking a line AB. So my AB will be the x. Okay. Then I am extend it up to 1 unit, that will be C. So this is my 1 unit, this is my x unit. So AC will be x plus 1. That means wait. And again crack it, that AB plus BC. So AB means x, BC means 1, so that will be x plus 1. And now I have to crack the midpoint of AC. That how we can find AC by 2, that will be x plus 2 by 2. So this is my midpoint of AC. I am mentioning it as O. Okay. Now the thing is, you have to create a semicircle of OA radius. So here putting the compass point and take the radius as OA. OA means x plus 1 by 2. This is OA, this is OC. Because I am writing this equation. So you have to make a semicircle by compass. Okay. Now here you take here you take the perpendicular line from the B and join these 2 points. Okay, I am writing this name as D and join O and D as well. So OD. So what is my OB? So OB is just OC minus BC. So that is OC means x plus 1 by 2 minus 1, and that will be x minus 1 by 2. So this is my x minus 1 by 2. And here XD OD is the radius as AO. It is the radius. And that was x plus 1 by 2. So this is my x plus 1 by 2. So this is what BD. So here you can, BD is just root over OD square minus OB square, and that will be root over x. So this length is root over x. Here I am taking the point as 0. Here I am taking the point as 1, and so on, and just make point here the compass and radius, take the root over x length, that is here I am putting the pencil here and taking the radius it, and just make a arc on this real line. Okay. That will be look like this. This was happened. Okay. So that is my E. So BE. Okay. So BE will be my root over x length on real line. Because here B is representing the 0, here C is representing the 1, and E representing root over x. So here it is the root over x position. Okay, this is for today. I am ending this here, and we shall be come back. I will be come back with another topic, and of course I will discuss it again in the next session. Till then, thank you for joining. Jai Hind. Have a good day.